Hello, my name is John Hoover. I am an Appleland board director and a marketing director at Tellabs. I'll be your moderator today, and I'm pleased that you joined and glad to welcome you to this Appleland webinar titled Alternative Designs Where Passive Optical LAN Thrives. We have 45 minutes of content, which will leave us plenty of time for Q&A at the end. When you have a question, please type it into the Q&A field. You'll find it in your Zoom banner menu. And we're going to get all the answers to your questions as time permits at the end of this webinar. This webinar is being recorded, and we will post it on the Appleland website. We'll provide you a link to that website replay in a post-webinar email, and you can share that with your colleagues that have similar interests. So with that, let me go ahead and introduce our speakers today. We have three presidents, three sitting presidents. First one is Jeff Van Horn, president of Uber Data. Jeff's very active on the marketing committee for Appleland. We also have Alan Birch. Alan is president of Qwipsys. He's a former board chair of the Appleland Association, and he currently sits on as a board of director with Appleland, and he's active on the marketing committee and also co-chairs the membership committee. And then we have Jeremy Kindle. He is president with Edge Power Solutions, and Jeremy is active on Appleland's technology committee. I love the topic that we have today, and these guys are going to provide some great insight to all the design variations that you can do with passive optical LAN. It has some very unique features to it, and you can use these to your advantage. And all three of our speakers are going to speak to how that can be done. Jeff's going to be first up, and he's going to go through kind of the alternative architectures relative to wired solutions. And then Alan's going to step in and talk about the synergies with passive optical LAN and wireless architectures. We really don't think about that or speak to that much, but truly there's lots of great things that can be done when we combine these two technologies. And then Jeremy is going to bat cleanup. He's going to come in and talk about all the different powering choices that you have, whether they be passive optical LAN or perhaps some of the wireless endpoints as well. So with that, I will go ahead and turn controls over to Jeff Van Horn, and he can get us started.
Thanks, John. Appreciate everybody joining today, and welcome. Thanks for taking part of your day today to learn about passive optical LAN and alternate architectures. I'm Jeff Van Horn, president of Uber Data Networks. I've been in the passive optical networking industry for well over 20 years now, working for equipment manufacturers. I worked with system integrators as an IT consultant, and now I am owner of a system integration firm specializing in passive optical LAN solutions. So today, we're going to talk through some of the unique architectures that we can put together with passive optical LAN solutions. And these are some of the things that we enjoy doing with our customers and take advantage of the flexibility of this technology on unique solutions. So kind of want to start off, I know many of you probably have been part of these presentations in the past. Some of you may be new to the passive optical LAN discussion, but this technology has been around for quite a long time, especially on the enterprise side, using it inside corporate office buildings and hotels. The technology is firmly established in a handful of market segments, and really the two leading ones, hotels and corporate office buildings, rather common these days. Really, hotels was the first major market segment to address the technology. Marriott Corporation, back in, I think, 2011, brought the technology to their labs from multiple manufacturers, tested it, and approved use for, started off with a lot of their larger hotels, and subsequently has integrated passive optical LAN and GPON technology specifically into all of their brand standards. So really, Marriott kind of paved the way, and many other hotel brands and independent hotels have adopted the technology. This tends to be one of the major market segments for the equipment manufacturers and the system integrators that provide these solutions, and it is very widespread in that industry today. The other segment that it is very common in is kind of what we call corporate office buildings, corporate buildings, headquarters, where office buildings essentially, and that also has been very, very common. Fiber to the desktop, fiber to the conference room, fiber to the training room. A lot of large corporate customers that you can see here have used the technology over the years. There are a handful of very large Fortune 100 companies that use this technology broadly that really the system integrators and manufacturers aren't able to mention due to NDA, but this is a very, very widely used technology in these market segments. So really don't want to focus on those today, but want to talk about some other architectures that you may not be familiar with that provide a lot of different architectures based on the flexibility that passive optical LAN offers. And so when you look at the technology and what we can do versus what we've been doing for 25 years, it allows us to do things that are fairly unique and optimize a network based on unique aspects of a given environment. So we're going to talk today about some expansive campus networks, very long distance networks, high scale networks, and then networks that that have logical and physical attributes that are different. And really, this is all enabled because of how unique passive optical LAN is, the use of fiber optic communications, the distance that it provides. So really, when you think about the designers of a building, if it's going to be an architect, an engineering firm, an IT consultant, this really opens the door to new ways of doing things that they haven't been done before. The concept of a 100-meter distance limitation of a Cat6 copper cable doesn't exist anymore because of the distance of fiber. We now have passive infrastructure instead of an active infrastructure. So now we're eliminating communication closets, power systems, cooling systems, switchgear, those types of things. And then we have a central management. So we can have these very large networks that are managed from a single management entity that is software-based, graphical, user interface-based, that makes these networks very easy to manage and maintain. So really the attributes that allow us to do these neat things is, number one, long distances. I mean, you're familiar with passive optical LAN. We always talk about the distances. Single fiber with GPON and PON technology, we can go 20 kilometers passively, which is 12 miles. 18 miles, and that has an impact on split ratios and other things that you need to take into account. But either way, we're looking at very long distances. We're not 100 meters, we're 20 kilometers. So that opens up the door to doing some neat things. Flexible configurations in the passive splitters, we can stack and cascade optical splitters so we can create things like trees, hubs, spokes, combination of all of those based on what that unique environment requires. And then one of the very powerful features of the technology is service integration, the multiple services. We're integrating things like data and VoIP phones, wireless networks that Alan will talk about next, access control systems, security, building automation, machine to machine and manufacturing environments, LED lighting, smart speakers, and then distributed antenna systems that Al's going to touch on. So a lot of integration and a lot of power that all comes under the control of a centralized management system. So let's talk about a couple different environments, and I want to talk about the characteristics and kind of what they do, and then we'll jump into some graphics. So we're going to touch on a big campus environment. So think higher education, universities, corporate office campuses, municipal networks, and these are usually multiple buildings, different building types, multiple service requirements. So we're going to do things like, think of university, fiber to the classroom, fiber to the lab. We're still serving administrative offices, conference rooms, maybe other on-campus things like dorms and amenity areas. So when we look at a network like this, you know, we have, and usually in the university is a really good example, usually multiple data centers in university environments. So we're going to have two different head ends. And one of the things we can build with passive optical LAN is geographically separate OLTs, which are the head end switches. So now we can provide geographic redundancy on a campus. And from there, we will drive different services out to the building. So when we're serving the schools, the administrative buildings, the labs, the university, classrooms, all the different buildings, typically those require redundancy. And we can provide path redundancy and equipment redundancy based on service from the two data centers and provide services to those remote buildings. Now, the nice thing with passive optical LAN is there's really only two moving parts. You have the optical line terminal, which is the head-end Ethernet switch, and you have the optical network terminals, which are the devices that provide handoff to the copper Cat6, gigabit Ethernet, 10 gigabit Ethernet interfaces to the end devices. So within these remote buildings, we don't have data centers, we don't have main data rooms, we have optical splitters, and then the ONTs provide service within those buildings. So now we're providing redundant services to the school buildings, and at the same time, we can provide other services off the same fiber infrastructure, the same head-end equipment to things like dorms and outdoor communications and emergency services. So with this, we're providing services to the dorms, and that could be fiber to the apartment type services for managed Wi-Fi and all of the amenity areas within those dorms. And on the same fiber network, we can provide communications throughout the campus in the form of security cameras for safety, wireless access points, and also the emergency phones that are around the campus. So now we have a fully converged communications network, very high availability due to the redundancy, high security based on the fiber, simplified operations. And again, when we have fiber infrastructure, that gives us a lot of flexibility and power from an upgrade perspective. So let's move on to larger warehouse environments. This is one of my favorite market segments just because they're so unique and so challenging, and the value that fiber optics provides is so high. So we'll look at very large structures, and you think about distribution centers, manufacturing plants. You're typically looking at facilities that are anywhere from 500,000 square feet up to 2 million square feet, sometimes even larger, single or multiple buildings. Usually in these type of environments, you'll find IDF cabinets mounted up in the ceiling or along the walls up above the floor, just because floor space is so valuable. This is very common in warehousing, distribution, and manufacturing. And so now we're going to be running fiber optics directly to the machine. In these environments, security cameras are very, very dense. So we're doing fiber to security cameras, access points. Industrial IoT is a huge growth area right now. And then, of course, there are business offices in these facilities too. So what's unique with the fiber infrastructure on these types of facilities is, again, we've got a main data room, and it's very small from a space requirement within the room, where your optical line terminal, which is your head-end Ethernet switch, is launching single fiber optics into a fiber backbone within the network. And instead of having IDF cabinets, like full cabinets with Ethernet switches and UPS and sometimes small cooling systems on those cabinets up in the ceiling, we're eliminating these active IDF cabinets. We're putting things up there like a passive fiber hub. So you have your optical splitter up there. Sometimes you'll have remote power slides up there for remote powering, but we're eliminating the IDF cabinets in the ceiling and all of the active managed equipment that's up there, and we're replacing it with a passive device. And so we're eliminating things like UPS battery backups up in the ceiling that requires a scissor lift to get up to. We're doing things like centralized remote power. Since we have a 12-mile distance, we can cover very, very large warehouse environments with the power of the fiber optics. When we're dropping down fiber instead of Cat6 cable, and typically in these environments, it's shielded Cat6 cable, there's need for a lot of conduit. And since we're running fiber that's not susceptible to EMI and RFI, we're reducing the amount of conduit that's coming down on the manufacturing floor and reducing conduit. Everybody loves that because conduit's very expensive. And since we're looking at things like 40-foot ceilings, that is a lot of conduit. And then above the ceiling, and we always tend to address things below the ceiling and above the ceiling in the passive optical LAN world, we're still providing connectivity up in the ceiling for the access points, the cameras, the IIoT gateways, and things like that. So we're providing unified management. We're converging all the services, including the IIoT, within a fiber optic network, and that provides a lot of savings, not only on a capital deployment side, but from an operational perspective, which is really the value of this technology. The operational savings due to the simplicity, the ease of move, add, change, and things like that ongoing is very, very compelling. So let's talk about extended distances, multiple sites and very, very long distances. And this is a market segment that the technology is really starting to get some traction in, and that's in the transportation market. You look at rail yards, railway main lines that are in signal territory, public roadways, municipalities, perimeter security control, things like that. And we're running fiber to security cameras, a lot of sensors, signaling systems, and then a lot of industrial IoT that's involved in these market segments too. So this is a very, very busy slide, but it's a very interesting slide too, because it shows you the power that we can provide on, and this is a good example, on a railway line, where we have these optical line terminals that can be spaced 40 kilometers apart, right? So we have a 20-kilometer distance on a single leg of the passive optical network interface, and we have an OLT with an optical splitter, and we can place ONTs along the rail line in this example, and we can connect things like rail line sensors, security cameras, wireless access points, and other wireless technologies along the rail line. So now you've got an OLT running 20 kilometers to the east, 20 kilometers to the west. We can tie the OLTs together with long-haul single-mode fiber optics and do the same thing 40 kilometers down the line, and keep doing that all the way down the line of a signaled rail line, where we pick up on the other side redundant wide area networks. So now we have protection and redundancy on that network, where if your primary network interface goes down, the secondary network from the far end picks up and provides that redundancy that we need. So this is just a really interesting example of really long haul, long distance needs are easily provided through this network. And again, centrally managed by a central management system that makes operations very easy. Last example here, physically segmented services. So when we look at multiple network operators in a single facility, and so think of things like multi-tenant buildings, airports is a very fast-growing environment for this technology, and casinos. So we're doing things where we're putting in a single fiber optic infrastructure, but we're allowing multiple management entities to manage and operate that network over a single fiber infrastructure. So in this example, we're using OLTs with different wavelengths. And there are some of the next generation PON technologies. NG-PON2 is an example. It defines multiple wavelengths, and we can have these ONTs and OLTs on specific wavelengths, and we can run unique wavelengths over common fiber infrastructure and allow different, completely separate entities to operate a network, providing logical separation and physical separation at the equipment level, but common physical network from a fiber infrastructure. And that provides a lot of value when you're looking at a single fiber infrastructure throughout a large environment that requires multiple operators. This allows us to do that over one single fiber infrastructure. So with that, I'm going to hand over to Alan Birch, and I hope you found this information valuable.
Thank you very much, Jeff. I appreciate that. I'm Alan Birch, President of Qwipsys, and I'm going to speak to you a little bit about the synergies of introducing wireless networks to your optical LAN. We just saw some really good information from Jeff on the flexibilities and options of the infrastructure. So what we'd like to do is leverage that to discuss, utilizing the infrastructure for Wi-Fi as well as cellular networks, and then talk a little bit about the considerations for converged network design. And we refer to it as converged networks because an optical LAN really is an access network, and now we're introducing Wi-Fi or 802.11 access as well as cellular RF access to the same infrastructure. And then we're actually providing a network case study to kind of overview the elements and benefits of the designs. Excuse me one second here. Oh, there we go. Sorry, I'm a little control challenge this morning. Sorry, it's taking a second to load. Okay, here we go. All right, so when we start looking at wireless considerations, they typically fall into three main categories, things that you want to look at when looking to overlay these technologies. Two of them are the same, regardless of Wi-Fi or cellular, the building and the physical, whereas the Wi-Fi introduces logical considerations. Wi-Fi is utilizing the Ethernet connectivity of the optical LAN, whereas your cellular infrastructure or cellular network is just leveraging the fiber and more than likely power elements as well. So if you look at the building impacts, first thing you think of is the closets. Jeff outlined very clearly the reach, the length that you can go with the fiber. When you start to introduce power, now there's some copper elements in there that impacts that overall capability. So if you're looking at remote power options, you have to look at dispersing closets a little bit more frequently than you typically would. And the value proposition kind of goes like, we can take a look at using just one closet and feeding everything from a central point. Do we need two closets in every floor? Or the answer is typically somewhere in between. And those operational benefits and challenges are what kind of drive that decision-making process. As far as pathways are concerned, delivering a fiber or a pair of fibers or a composite cable fibers and copper for power, to a multi-port device offers the ability to massively reduce the amount of infrastructure that's in place when cable feeding 1, 2, 4, 8, 16, 48 devices. And additionally, it provides some alternate routing capabilities as well. Even though you might have a camera on the outside of the building, fed by a Cat6 cable back to a closet within the building, you've now got the ability to actually extend fiber out to that camera location, deploy a network element, and feed the cameras. So how you're getting fiber or composite cables through the buildings versus category cabling would be slightly different. You look at the edge, what we're talking about is out where the end user devices typically dwell. So again, that camera location on the side of the building, wireless access points, typically in ceiling locations or pole locations. A lot of your cellular devices are going to leverage the same type of deployment, where they're going to happen in the ceiling or sometimes external to buildings or on poles. The ceiling application, they've got the options to, in most cases, to actually use the cellular Wi-Fi component for the onboard radio. There's also options for adding external antennas. So it's basically considerations around the aesthetics and functional operation of the location of the devices. The concept is to establish an edge point where when you change a wireless access point, you get on a ladder, you change the access point. If you've got a modified technology to support that next generation, you're then also adding that generation, ONT to support 10 gig PON versus the GPON you've installed to support active Ethernet connectivity back to the head end versus a PON standard. So it's a ladder, one ladder deployment, some configuration at the head end, but you're not ripping and replacing infrastructure any longer. You look at the physical attributes of the deployments. You need to take a look at power first, and Jeremy's going to give you much more detail and options here, but basically kind of boils down to local power. Do I need a AP, plugging into something right there at where it sits, or are we going to feed that device, using power over Ethernet or like a cellular device we're feeding, neg 48 volt over long runs? Those power requirements obviously have impacts on the closets, because now we've got to, make plans to deploy that stuff in a closet. It's obviously going to impact the size of the pathways and also, what you've got at the edge of this network. When you look at location, again, we're talking about the location of the deployment of devices. The stuff goes in 50% of the time in new construction. It's easy to design and deploy access systems, ceiling hatches, boxes, wall boxes, et cetera, like Jeff had talked about a little bit. But in a retrofit, it's not always that easy. If you've got to get from here to there through hard pan ceilings, it becomes a little bit more of a challenge. So planning for that in new construction is critically important. And then lastly, connectivity, right? The wireless access point, the most common deployment is going to find a category cabling, pushing PoE, from a switch or in our environment from a network terminal, the last 3 to 300 feet to this device. But as the Wi-Fi continues to evolve, and it's one of the fastest moving end user devices that we see on these networks, next generation stuff might provide, be required to have multi-gig connectivity, multiple Cat6 connections. We've seen wireless access points that have fiber-based backpacks, so the type of connection that's going to happen out there is critically important, and again, puts more impetus on your ability to define a pathway cabling infrastructure that's going to support what you're putting in today, as well as what might come down the pike, 3 to 5 years from now. Then from a logical perspective, and this is really, more towards the Wi-Fi, the cellular stuff, the RF is usually infrastructure for connectivity. But with Wi-Fi, it's critically important to understand the impacts of the bandwidth. That can impact the number of splits that you're using on a PON, the number of devices that you're putting on a PON. But it's also really important to understand that the bandwidth conversation is not just a simple math equation. Take a 2.4 gig PON link divided by 24 legs and think you have a 100 meg solution, right? The dynamic allocation provides for more. But you still need to be mindful of the capabilities of that radio, and you don't want to put a dozen wireless access points onto a single PON leg with 2.4 gig in the back end. The nice thing about the optical LANs, utilizing GPON technology or XGPON technology or even active Ethernet connectivity, is it provides for a lot of options for delivering bandwidth to these locations and the flexibility to install GPON today and upgrade to XGPON variants or active Ethernet tomorrow. VLANs are critically important. You network administrators out there know what I'm talking about. And when you take a network that's got a bunch of VLANs anyway, and then you put a wireless access point providing access to dozens and dozens, hundreds and hundreds of additional users, it becomes quite cumbersome on the network. We've seen this application quite a bit in senior living, where every resident within the community has their own VLAN. It gives them the ability to print something from their tablet out by the pool back to their printer in their apartment. And this flexibility is amazing for the end user experience. It's a challenge for those of us building networks. Then the last logical consideration would be the Wi-Fi, or excuse me, the security. Right, it's a very common thing across most wireless access point platforms or Wi-Fi platforms to have some type of identity services engine out there. It's basically what's accommodating credentialing of users to that device and allocating network access to the end devices. So it's something you want to be very mindful of as well. So we've got a design here for a project that was done a couple of years ago, and it's a 500,000 square foot headquarters facility. This is an eye chart. I don't expect everybody to memorize the bits and pieces. But if you look at some of the boxes, you see a lot of the elements that we discussed. We've got remote power capabilities in here. We actually utilize digital electricity in this deployment, and Jeremy will touch on that briefly during his segment. But in this design, there are actually two distinct networks that were built. There was a network that was built through the floor. And what we did is we took network, fiber, as well as digital electricity, two IDFs, did conversion, put the fiber down through the floor into aggregation boxes in the floor where the fiber split and picked up the power, went to composite cable out to the end user devices. End user devices in the floor network are typical workstation stuff, audio visual printers, conference room schedulers and the like. There's a second network in this building, and it's the ceiling network. And this network doesn't do all the splits and stuff in the floor. It actually does its splits and power conversion in the closets. But the concept was to run 12 strands of fiber to these aggregation boxes. What the aggregation boxes did was allowed you to terminate multiple strands of fiber into optical network terminals and then deliver short runs of category cabling to BMS and wireless access points and security camera and ceiling stuff. So it created the flexibility to put next generation stuff with only short runs of patch, copper in the ceiling, and it created the flexibility to demount the walls, reconfigure the workspace, and reuse the infrastructure, network and cabling infrastructure to reconfigure the workspace. Later in the project, the conversation was brought up that we should be looking at the potential of doing cellular in here as well. And then we took a look at what we had in terms of infrastructure and what we needed to do to add a cellular DAS, and that's represented here in the stuff that I highlighted quite clumsily in yellow. And the incremental cost of this DAS was to put in the carrier head end, the DAS or cellular head end, and then to leverage the existing fiber and power to install optical remotes out in the ceiling. This is a bit of a misrepresentation. This thing actually sat on the box using an external antenna for aesthetics to the actual ceiling itself. But now, instead of a standalone DAS that had all the head end, had all the remotes, had all the fiber connectivity, and coax out to antenna locations, essentially the net incremental effect was to add the cellular active electronics to it, and then to take the patch cables from these aggregation points in the ceiling and deliver connectivity out to the remotes. Why was this possible? And then this generated like 50% savings on the DAS, by the way. The reason it was possible is because this cabling infrastructure had a very significant backbone. We designed it, honestly, to be DAS ready and future ready. The flexibility that to put on technologies that they hadn't quite prepared for. That would have helped us to get to the closets, with the backbone. But having that significant fiber presence to those ceiling boxes was important as well. And any of you that pull fiber know that if you need one fiber, you always take two. If you need 6, you might as well take 12. The incremental difference in the fiber is negligible to the labor associated with pulling it. The fact that we had created peering points in the closets, in these floor boxes, and in the ceiling boxes creates the flexibility to do moves, adds, changes, to implement new technologies, again, without having to make a significant impact on the infrastructure itself. These become exercises at the edge, exercises at the head end, and programming, not a massive cabling project. From an optical LAN perspective, the nice thing was we had modular head end, actually head ends for redundancy. So we used the GPON and a mix of Active-E connectivity for end user devices. There was some audio visual stuff that for timing consideration, they wanted to use active Ethernet connectivity. So we used Ethernet connectivity here to provide for the LTE, but future considerations around 5G and IoT or small cell implementation can leverage existing active Ethernet ports or the extra fiber and power infrastructure that was installed. And then lastly, in terms of the cellular DAS, I think 50% savings was is what we ended up with here. I think we're all pleasantly surprised that we ended up getting it. The fact is that most of these are typically on the 20-25% savings, but it ended up being just the perfect storm for the system. And I look forward to chatting with you a little bit more about this during the Q&A if anybody has anything for that. And I will hand it over to Jeremy to discuss powering options.
You doing okay with the control, Jeremy?
Yeah, I'm trying to, my page down doesn't seem to be working. It's going straight to questions before our speakers.
Yeah. Okay, let me take back control and I'll get you to a safe place. And why don't you just go ahead and introduce yourself?
Hi, good morning, everyone. My name is Jeremy Kendall. I'm with Edge Power Solutions. Been in the GPON industry, in the optical LAN industry for about 10 years, communications industry for close to 30. In the power industry for the past 5 years. While working with the PON Technologies, decided to dust off my 30-year-old electrical engineering degree and try and do something good in the power arena for upcoming technologies with respect to remote power.
Okay, Jeremy, you should have control now.
Good deal, thanks. Yeah, I want to thank the Association for Passive Optical LAN for the opportunity to talk about the importance of power, as many of the technologies move from a copper-based to a fiber-based as it's becoming the preferred transmission medium. Still doesn't seem to be working, John.
I'll move the slides for you.
There we go. Okay, thanks, appreciate it. When I talk about the importance of power, let's don't confuse that with it being interesting. Power is basically an on or an off. But when it comes to powering, many of the technologies that Jeff and Alan spoke about earlier, there's really basically two choices. You have local power, which usually consists of in the form of a local AC outlet, an adapter port of some sort. And then you have remote power, typically a centralized or closet distributed NEC Class 2 low voltage system or a PoE. And that's the PoE is what most people are used to today. There are uses for all of these and questions to ask when deciding which to use. A typical question and revolving around the ONT. An ONT type, is it a surface mount or an in-wall? The location, is it in an enclosure, above the ceiling, exposed surface mount? Areas where that power adapter wouldn't look nice in a conference room, something like that. Do you have backup requirements, life safety? What's on that end device? Is it building management system, something life safety, a phone that's required? And do you require any intelligent power controls, remote power reset, output monitoring, fault monitoring, or any type of recording? We'll go to the next one, John. With local power, you could see some cost savings in local power if the area where you're installing equipment already has existing AC, such as in the cube farm under a desk where there's already outlets, or in a typical office, something like that. But in most part, the cost savings would go away if you required any type of backup. The disadvantages of local power, as you can see in one of the examples, the aesthetics. If there's an area, like I said, a conference room or an office, local power isn't always the prettiest way of installing, but in a cube farm or behind equipment or enclosures, usually it's a viable way to go. Now, cost of backup, you need to back up your end devices. If you were using local power, then obviously you would need a UPS or a device such as that to back up each one. So that would drive your cost having multiple UPS units. Go to the next one, John. Now, there's several advantages to remote power. We're seeing remote power as the preferred method of power across several technologies, not only optical LAN, but Wi-Fi, distributed antenna systems, security, and we've been seeing a lot of LED lighting recently. The increased needs of power and versus the capabilities of PoE and the distances allowed by PoE, I believe we're driving this trend combined with the use of fiber. Recent advantages such as remote power monitoring, remote power reset have been a big step in the industry. You might ask why, and it all comes down to cost savings. If you have the ability to remotely reset an ONT, a DAS remote, an access point, a camera, etc., in an environment such as Jeff talked about, a factory environment, a large-scale facility, a campus, a railway, or if you have a managed services environment, the ability to power reset those devices from your desk saves time, money, and resources. In addition, we have the, you stay on that one. In addition, we have the aesthetics. In the examples here, you can see remote power, which is NEC class 2, 56, 57 volt power. It's hidden in the walls, can be hidden more easily. Doesn't require conduit. In most areas, there are some jurisdictions that do require it to be in conduit. You have a centralized backup capability. So if it's a closet-fed system, you can feed each of your remote power units with a dedicated UPS, or it can be fed from a centralized digital electricity plant, such as Alan talked about earlier, or just a high voltage DC plant in general. You do gain some centralized maintenance. It's easier to work on a device or power down a device from a closet location rather than disturb with someone at the end unit, and you also get those intelligent power controls, like I said. Might require slightly more TC space, but some of the technologies are combining splitters now with the power so that you can use less space. And in an instance, that might result in some higher cost because of that TC space, but usually a savings versus the localized power and the backup and especially if you do not have power in those locations already. Go ahead, John. There's some design considerations when choosing your plant, your power plant. Critical network equipment, you want to lay out what's the critical network equipment, what needs to be backed up, your infrastructure and NEC requirements. Like I said, NEC does not require low voltage cabling, remote power. If it's 100 watts or less and 60 volts or less, it does not require conduit, but there are some jurisdictions, like one I'm in today here in Chicago, that does require conduit, but it's just something to be aware of. Backup requirements, like we talked about before, UPSs or a central high voltage DC plant, such as digital electricity. The nice thing about that digital electricity, so with a typical remote power solution, with your 56 volts at 100 watts or 57 volts at 100 watts, you're going to get increased distances near matching the fiber of the facility that you're putting in there. We're not going to get 12 miles, and we're not even going to get close to that. But we can get, depending on load, 800, 900, even 1,500 feet on that copper pair. And if you fed that with digital electricity, which has extended reach from beyond that, you can get into those thousands of feet. And then you got the digital electricity feeding a remote power supply. That remote power supply feeding an ONT. You've got that thousands of feet, and then from that ONT, you've got your 100 meters. So you can see with the fiber, you can get much farther distances with your power. You want to plan for day one requirements. Like the biggest question I get all the time, probably 3 or 4 times a day, we'll get a call. I have this many units. I have putting a phone on it, an access point on it, and a PC. I'm going, what size wire do I need? Many of the AppleLAN members have cable calculators on their websites. This is just an example of one, but you really need to know the load you're going to have on your device, how many feet you need to go, and know the optimal operating power of your device. For example, ONTs have a nominal 48 volt power requirement. We know from our research that 51 volts is best just about across the board from all manufacturers. So if you know those going in and you know your loads going in, you can use those calculators to dial down on what size cable that you need and how far the distances you can go with those cables. Now, you want to also plan for future overhead. We always get that same question. Well, can we get away with a 16 gauge cable or an 18 gauge cable? Well, keep in mind that you're putting in an infrastructure with fiber that, especially single mode fiber, that really doesn't know the bounds yet. So you want to make sure you want to kind of make sure you future-proof your power as well, especially as power needs to go up on access points, security cameras, and things like that. when you look at your power conductors, one of the advantages and savings that you could realize if you've already have legacy copper in place, you could utilize the existing Cat5e or Cat6 within the walls. You do want to keep in mind that if you combine four cables for your positive and 4 cables for your negative in a Cat6 or Cat5e environment, you're really only getting the cable equivalent of an 18-gauge cable. Me personally, I prefer a dedicated copper pair. There's several hybrid fiber and copper cables out there that's becoming quite popular, and then we've already discussed the conductor size. You go to the next one, John. This is a sample remote power diagram. Again, very simple. This example is obviously an optical LAN, and it's using one of the power supplies that I spoke about that does have a built-in fiber optic splitter. And what you have here, and it saves the space, but what you have here from your OLT out to your IDF closet, you would hit this remote power supply splitter and take out to your ONTs whatever gauge cable, be it a 12 gauge, 16 gauge, 24 gauge, proper gauge out to your ONT and provide your fiber optic connection as well as your power connection to that ONT, then out to your end devices. And that's all I got today. That's like the power's not that exciting, but there's new trends coming.
Okay, thank you, Jeremy. Next, let's get to some questions to our expert panelists. I only see 3 coming in, so I'm going to give you all some time to type in some more questions. And while you type, let me go ahead and just give you a little background on the association. We are a group of manufacturers and integrators and architects and engineering firms. And we've come together to promote and educate people on the technology of passive optical LAN. And we're trying to get out there and formulate strategies that better market the design, installation, educate, and support this technology. You can see here we have some top companies already a part of this association. And we do a lot of great work, and we really want to reach out to the community and ask you to join us, help us out with this effort, help us impact research, do webinars like this, do training events like at Dixie, push out great content to media outlets and author articles in trade magazines. So I really encourage you all to join this association. Okay, so let's get to the questions. I'll go with Alan first. I'll give you this one. How does passive optical LAN work with 5G?
Well, that's a really good question. I always make this statement, 5G is not a thing so much as it is a strategy, right? A collection of things. And there's different 5G solutions out there, different manufacturers. And the commonality with them is that they're all fiber connected directly, leveraging, Ethernet, backhaul. So if you take that headquarters project, for instance, the flexibility in that ceiling enclosure to support, additional Ethernet connectivity, the fact that there's extra powered fiber in there in case we have to put a millimeter wave or CBRS radio up there that's, direct to connect back to an RF, based head end. The flexibilities in the infrastructure and even in some of the network elements to support that 5G stuff, kind of whatever it looks like. I wish it was ABC companies part, 1, 2, 3. Unfortunately, there's still not a super clear direction for what that stuff is going to look like and what the connectivity is going to be. But I guarantee it's going to be one of the 3 things that's sitting up in that box.
Okay. This one may go to Jeff or Jeremy. How do you handle PoE over a PON network?
Hey, let me take the first part of that, Jeremy. I'll let you talk about the powering piece of it. So the PoE on passive optical LAN, the capability from the ONTs, the gigabit Ethernet, the 10 gigabit Ethernet ports, really isn't any different than a traditional workgroup switch in a traditional network. So the PoE is all your standard PoE. A lot of the newer ONTs are coming out with 4P PoE capability, up to 60 watt. 90 watt is also starting to come out too, and some of the currently ratified standards. So from a PoE perspective, it works the same. All the ONTs support things like LDP for doing power management, reporting, statistics, things like that. The only thing you need to be cognizant of, and it's the same for a traditional network, but probably a little bit more so in the PON world, is the ONTs have a limited PoE power budget that each of the manufacturers specify. And for example, one of the some of the smaller ONTs have up to 60 watts of power over Ethernet capability. well, all the ports can provide 30-watt PoE. There's a maximum, capacity of the device, just like a work group switch. And when you're connecting things like IP cameras that, some require 7 watts, other require 30, you just need to be aware of those power budgets. And sometimes you'll need to limit connectivity of the number of cameras on a given ONT. But again, that's kind of the power budget thing you calculate. And then I'll let Jeremy answer the second piece of this, is what to do to your remote powering capacity.
Yeah, thanks, Jeff. Yeah, it is important to know your PoE budget at your ONT. If your ONT has a capability of 160 total watts, and we're feeding it with an NEC Class 2 circuit with only 100-watt capability, you're going to fall short. And that's no different than in a traditional switch. You have to sometimes put that second power supply in there to get the full PoE out of all of your ports. But it does play a role in that. And then with some of the newer units coming out, we are offering a lot of companies are offering the ability to parallel outputs. So you can still get the NEC Class 2 wiring, but you take 2 outputs from your remote power, then now you have 200-watt capability. There are some NEC requirements associated with that, but the capabilities do exist.
Okay, let's, Alan, I'll give you this one. Well, I'm going to paraphrase, but it says, how do you handle next generation Wi-Fi? And I'll throw in there, yeah, we all know another generation of Wi-Fi is coming right around the corner. So how does this network handle whatever comes at us next from a Wi-Fi standpoint?
I think it comes down to the connectivity, right? The bandwidth is one thing. If you've just got one Cat6 cable feeding a wireless access point, and that AP is capable of certain bandwidth, and next gen is greater, that's one set of problems, right? How many APs have I set on this PON or on these links? Does the bandwidth start to outpace the capability of a GPON to support it? So now do I have to look at XGPON? Do I need to look at modifying this to become an active Ethernet link? But the real big gotcha is when you start going to multi-gig connectivity to these devices. Because it varies by manufacturer, but the response to it's going to be to stick probably a new network terminal at the edge that can support lagging a couple of the Cat6 cables into that radio. Again, not to harp on it, it's not like a total fiber geek, right? But the fact that we created a fiber point to the point in the ceiling and a network aggregation point there to support the next generation of what if is the big valuable thing. Whatever that looks like, there will be technologies and devices available to support it.
Yeah, and this kind of relates to another question. Someone was typing in, where do you see demand for 10 gig passive optical LAN? And certainly the Wi-Fi is going to drive that. Certainly that's an instance where you may put those Wi-Fi 6 WAPs on XGS-PON, maybe just go ahead and have those wavelengths travel over the same infrastructure that was already there. And then even down at the ONT, use multi-rate Ethernet to either put a 5G or a 2.5G Ethernet endpoint right on that ONT, right next to that Wi-Fi 6 WAP that's right there.
You should have taken that question. You answered it better than I did.
No problem. Okay, well, I'll give Jeremy a tough one. Jeremy, the question is, let me scroll down, and this is always tough, but what do you see from a price difference between local power and remote power, and then using digital electricity? What's the cost difference?
Generally, in most networks, I see the remote power being about 25% less at a minimum if you're looking at dedicated power for the devices. When you combine that with a digital electricity, what that does is give you additional reach and a better single source for backup power. Take the college campus example that Jeff talked about. The digital electricity has an enormous reach in the thousands of feet. So if we could have a centralized digital electricity power in the head and building of a college campus, and then a traditional low voltage distribution in the minimal IDFs that you would require to knock down that 300 plus volts of digital electricity to the usable 57 volts, then you've got a centralized backup covering an entire campus versus multiple closets with traditional low voltage power and a UPS on each one. So digital electricity has been a huge gain for the industry.
Okay, and Jeff, how do you roll out XGS-PON and NGN-PON in the future?
Yeah, so it really comes down to upfront planning, right? A lot of and John kind of followed up on the previous conversation about when you need XGS-PON. We're deploying it very often, and the K through 12 environment is a really high growth environment for us right now. And the wireless access points, the Wi-Fi 6, the multi-rate interfaces is really driving that right now. So we tend to do XGS-PON, kind of above the ceiling for the APs and then pick up the cameras and access control and things like that on XGS-PON, and then down, so to speak, below the ceiling for the data ports in the offices and classrooms. That runs off GPON. So you've got to plan for the infrastructure, and really the infrastructure only changes really in the MDF or where your OLT is at, right? When you have an OLT, you'll have a GPON interface and an XGS-PON interface coming off the same OLT, or maybe different separate OLTs, but they'll get combined by a CWDM combiner right there, and it's just a matter of patching. And then you'll go in your fiber plant, your fiber backbone is normal. So it really doesn't have a huge effect on the fiber infrastructure. It's more the planning up in the MDF, and then again your ONTs, depending on the ONT type that you deploy, it picks up the wavelengths that again are all common on that fiber infrastructure. But then those ONTs will pick up the wavelengths and operate either on GPON or XGS-PON. So kind of a long-winded answer, but it really is just about planning, and most of the planning's in the main data room.
Okay, I see some questions that are really getting down in the weeds relative to powering. Jeremy, come on, powering's interesting. I would just suggest that you all visit the AppleLAN website. You can find a list of member companies there, and reach out to those member companies if you have questions about installation or powering or ONTs or OOTs. That's just a great resource for you to gather information about this technology. We have reached the top of the hour. I do want to thank our speakers, Jeff, Alan, and Jeremy, for pulling together the content that they presented today, and certainly want to thank the association for providing this platform for us to give you some better education about this great technology. So with that, I also want to thank all the attendees of today, and remember that we're going to post the replay of this webinar up on the website. We'll send a link to you in an email. Please feel free to share that. And with that, I'd like to wish you all a great day and a great rest of your week.